Imagine replacing our Sun with a star so large that it would swallow Mercury, Venus, Earth, Mars, Jupiter, and even stretch beyond Saturn. A star so enormous that light itself would take more than 13 hours just to travel around its surface. This is not science fiction. This is Stephenson 2-18, currently one of the largest known stars ever discovered. In this documentary, we'll take you on a journey across the Milky Way to uncover how stars are born, how nuclear fusion powers them, what makes Stephenson 2-18 so extreme, whether it truly is the biggest star, and what its future holds. By the end, you'll understand not just how big this cosmic giant is, but what it reveals about the limits of the universe itself. Every star begins its life in a vast cloud of gas and dust called a nebula. These nebulae are scattered across galaxies like glowing cosmic wombs. They are mostly made of hydrogen, about 74%, helium, about 24%, tiny traces of heavier elements like carbon, oxygen, nitrogen, and iron. The story begins when something disturbs this cloud, a nearby supernova explosion, a passing star, or gravity itself. As gravity pulls material inward, dense clumps begin to form. These clumps grow hotter and denser as they collapse. Eventually, one of these clumps becomes a protostar. Inside the protostar, temperature rises above millions of degrees. Pressure skyrockets. Atoms begin moving violently, but it's still not a star yet. The real magic happens when the core becomes hot enough for nuclear fusion to ignite. Fusion is the process that powers every star in the universe. In simple terms, small atoms smash together to form bigger atoms, releasing enormous energy. Inside most stars, including our Sun, fusion begins with the proton chain. Two hydrogen atoms, protons, collide. They fuse into deuterium. More collisions form helium. A tiny amount of mass is converted into pure energy. This energy is released as light, heat, radiation, and this energy pushes outward. Meanwhile, gravity pulls inward. When these two forces balance, the star reaches hydrostatic equilibrium, a stable phase where it shines for millions or billions of years. But massive stars like Stephenson 2-18 live fast and die young. Stephenson 2-18 is a red supergiant star. Red supergiants are among the largest stars in the universe, formed when massive stars run low on hydrogen and expand dramatically. Key facts about Stephenson 2-18. Type: red supergiant. Estimated radius: 150 times larger than the Sun. Diameter: over 3 billion kilometers. Volume: could fit over 10 billion suns inside. Luminosity: 440,000 times brighter than the Sun. Surface temperature: 200 Kelvin, cooler than the Sun. Despite being cooler, it appears bright because of its massive surface area. Its sheer size makes it one of the most extreme objects ever measured. Stephenson 2-18 was identified within the Stephenson 2 star cluster. It was cataloged in the early 1990s by astronomer Charles Bruce Stephenson, who studied infrared stars in the Milky Way. Why infrared? Because this region of space is heavily blocked by interstellar dust. Visible light struggles to escape, but infrared can pass through. Location details. In the constellation Scutum, roughly 19,000 to 20,000 light-years from Earth, deep within the Milky Way's inner spiral arms, surrounded by dozens of other massive red supergiants. It remained hidden for decades simply because dust obscured it from view. Is it truly the biggest star? Here's the twist. Stephenson 2-18 might not actually be the biggest. Why? Because measuring stars this far away is incredibly difficult. Problems include dust blocking light, distance uncertainties, stellar atmosphere distortions, pulsations that change size, measurement methods that give different results. Some studies suggest its radius may be smaller than originally thought. It could be closer in size to UY Scuti. It may not even be gravitationally stable. Other contenders for biggest star include UY Scuti, VY Canis Majoris, Westerlund 1-26. So while Stephenson 2-18 holds the record in many charts, scientists still debate its exact dimensions. Massive stars evolve very differently from stars like our Sun. Stages. Main sequence: hydrogen fusion. Red supergiant phase, hydrogen runs out. Core contracts, outer layers expand. Fusion of helium into carbon. Fusion of heavier elements. Oxygen, neon, silicon. Iron forms in the core. Iron fusion consumes energy instead of producing it. At that point, the star is doomed. The core collapses violently. A shockwave rebounds outward. This results in a supernova explosion. Stephenson 2 to 18 is already in its final stage of life. It could explode at any moment, in cosmic terms. Predictions. It may go supernova within the next 100,000 to 1 million years. The explosion would briefly outshine its entire galaxy. It would leave behind either a neutron star or a black hole. Luckily, it is far too distant to harm Earth. But if a similar star exploded within 100 light-years of us, it could seriously damage Earth's atmosphere. If you enjoyed this journey into the largest star ever found, subscribe for more mind-blowing space documentaries. Like the video to support science content. Comment, which cosmic giant should we explore next? Because the universe is bigger, stranger, and more beautiful than we can ever imagine.